So welcome to this video for revision worksheet 14. So this revision worksheet, like revision worksheet 13, is just a mix of questions that have come from a series of different places, but mostly the mock papers and a lot of questions coming from the pre-project maths papers, which means they're not in the project maths style, but there's still some really good questions and really good to see. So let's take a look at question 1. So it says, let g of x equal to ax squared plus bx plus c, where a, b, and c are real numbers. So g of x is just some quadratic function. Given that k is a real number such that g of k is equal to 0, prove that x minus k is a factor of g of x. Now, let's break this down. So we're given a quadratic g of x is equal to ax squared plus bx plus c. We're told that k is a real number such that g of k equals 0. Now this is important. So effectively what they're telling us here is k is a root. Okay, so they're telling us k is a root, i.e. x is equal to k. So we know when we sub that in, we'll get 0. So we know that that's true. So let's have our g of k here. So we get a k squared plus b times k plus c equals 0. So this is like the first piece of information we've been given in the question. We're told that a k squared plus bk plus c equals 0. Okay. So then they want us to prove that x minus k is a factor. So if we want to prove that x minus k is a factor, we want to prove that anything is a factor. It's always the same way. We want to show it, so basically show it divides evenly. It divides in evenly. So that means no remainder. And that's important, and that's kind of going to be our logic we're going to use. No remainder. So let's go with this. Let's have our x minus k. We're going to divide it into ax squared plus bx plus c. So first division is slightly okay. Goes in ax times. So ax squared minus akx. So then we subtract. Cancel. This becomes a plus. And we're left with bx plus akx. Now, really what we want to do is we want to take that x, you see that x that's common? So what we end up with is b plus ak times x. And the reason we want to do that is for division purposes. When we divide x into this now, it very easily we can see goes b plus ak. So we get b plus ak times x minus k times b plus ak. Come along, this is subtractions, this cancels and this becomes a plus. So we're left with c plus k times b plus ak. And this here is our remainder. So that's what we have left over because we've done our division now. So we're trying to show that c plus k times b plus ak equals 0. And let's see if that's true. To make it a bit clearer, let's multiply it out. We get bk plus ak squared. Rearranging it, we get ak squared plus bk plus c. And this is equal to 0. How do I know it's equal to 0? Well, let's go back to this first piece of information that we had. Since g of k equals 0. So we actually had that missing piece, and I think this is where a lot of people struggle. They kind of got the idea, I have to do division, yet the division wasn't particularly nice, but managed to get through it and you got the remainder. It's then the question of, well, how do I show that that remainder is 0? Well, we were only given that extra piece of information, that g of k equals 0. So what we will say is, so since x minus k divides into g of x, just for shortening purposes, evenly, we can say x minus k is a factor. And I think this is a really good one to see, because the idea that x equals k being a root and going straight then into saying, well, then we have a factor. We have a factor of x minus k. We use this the whole time and we don't really question it. We kind of go, yeah, that's true. And this is really a very good proof of saying, well, why is it? I don't think you'd ever be asked to prove it now, but now at least you've seen it. So part 2 of this question, x minus t is a factor of this. Show that p is equal to minus t cubed all over 2 times t plus 2. Now there are 2 methods to doing this, and what I would generally say when there are 2 methods, especially when these 2 methods are either using the factor, which we've been given, or the root method is 99% of times much easier. You can of course use long division, but the long division here, given the number of letters, becomes very, very complicated. Sometimes people forget the idea of the factor and the root when we throw it into letters. They see it very easily when there's numbers, but not so much when it's letters. So to work with our root, we say 2x minus t is equal to 0, so 2x is equal to t, so x is equal to t over 2. That's my root, because our factor was 2x minus t. Now, if you do the long division, that's fine. I'm not going to do it here, but I am going to use the idea of the root. So I have 2x cubed plus px plus p. So when I sub in t over 2, everywhere there's an x, it will equal 0. Now, that is much more straightforward than trying to work with the long division. So the first thing we're going to do is we're going to cube out this fractions. That's t cubed over 8 plus pt over 2 plus p is equal to 0. Cancelling this down, I get t cubed over 4, because the 8 and the 2 cancel here, plus pt over 2 plus p equals 0. Let's multiply the whole thing by 4 just to get rid of the fractions, make it a little bit more straightforward. Plus, 4p equals 0. Now, look what we want. We want to show that p equals. So there's a p on its own. However, you'll notice that the p appears twice in ours. What that means is we're going to have to get the p's together in some way, and we do that using highest common factor. So the first thing we're going to do is we're going to get rid of anything that doesn't have a p, and that is the t cubed. So we get minus t cubed. Then we're going to use, I suppose, a more common factor than highest common factor, because we don't care if there's something else common like the 2, we just want the p. So we're left with 2t plus 4 is equal to minus t cubed. So now, to get rid of that, we divide both sides by the bracket. So it's 2t plus 4. Now, take a look at what we want. It's very similar. The only thing we need to do now is to take out a 2 from the bottom line. And we're left with t plus 2, which is exactly what you want. Done, as requested. So this is a lot more straightforward than using the idea of long division. So do be careful. Always kind of question and see, well, if I have a factor, can I use the root? Now, we did a question on worksheet 13 where it wasn't possible to use the root, so we had to use the factor. We had to do long division. In some cases, that will be it. But where possible, try to use the root. You'll find it will simplify your answer quite a lot. Now, question 2 from this, I'm going to do it in 2 different ways because I'm conscious that some people have focused on one method more than the other. Because this is an equation, because there is an equals there, sometimes people use a slightly different method than what we would use for if it was an inequality. So generally we see these modulus, so these 2 straight lines, these modulus symbols, we see them more with inequalities than we do with equations. So generally I would suggest using the same method for both, not to get confused, not to do anything too crazy then when you get into the inequalities. That would be my advice. I sometimes think the less you have to do, the better. So if you only have one method to remember, that will work for both. So anytime you see a modulus, you do this. Sometimes that makes it a little bit simpler. If you're happy with having a few different methods depending on the scenario and you're doing them correctly, then that's absolutely fine. So I suppose my preference for this will be to use method 1. And that's the idea of squaring both sides. So when you see an inequality, when you see a modulus, regardless of whether it's an equation or an inequality, to get rid of it, we square both sides. Remember that the logic of this absolute value signs of these modulus lines, what they mean is whatever is in there should be taken as positive. So if it is negative, we take it as positive. However, if it's positive, we leave it as it is. And that's a little bit complicated for us because we can't just ignore them because we might have had to change the signs, and we get into this, what should we do? We don't know what we should do because we don't know what m is. So what we do instead is by squaring both sides is we create a positive number. So we 100% know it's positive because the square of any real number is positive, and that's some logic that we use quite a bit, especially when we're dealing with inequalities. So what we're going to do in this case, we're going to square both sides. Now, I know some people kind of started with this and then said it got very complicated very fast. And yes, it does, but we're going to work through it. So minus 12x plus 9 is equal to m squared x squared. So I'm using the shortcut. Square the first, twice the first by the second, square the last. Now, what we have here is a quadratic. It is a complicated looking quadratic, but it is a quadratic. And focus here on the idea of only one solution, and that's important. Quadratic of one solution, we should be thinking discriminant. Okay, so b squared minus 4ac, and when that is equal to 0, there's only one solution. So in order to use that, we're going to have to get into a quadratic in a form we can work with. So we're going to have 4x squared, and we're going to bring the other x squared across, minus m squared x squared, minus 12x minus 2mx plus 9 minus 1 equals 0. So cleaning that up, I'm going to take the 4 minus m squared out in front of the x squared. Minus, I'm going to put a plus here, and minus 12 minus 2m times x plus 8 equals 0. So yes, it's a bit complicated. However, we have a quadratic where this represents our a, this represents our b, and this represents our c. So we can use the idea of the discriminant. B squared minus 4ac equals 0. So b squared minus 12 minus 2m squared minus 4 times 4 minus m squared times c, which was 8. Working that out, so we have 144 plus 48m plus 4m squared minus 32 times 4 minus m squared is equal to 0. 144 plus 48m plus 4m squared minus 128 plus 32m squared equals 0. So let's clean that up. We have an m squared, an m, a number, and a number. So I'm just going to bring this up here. So we end up with 36m squared plus 48m plus 16 equals 0. Now to simplify this, we can divide across by 4. So you get, so we divide across by 4, we get 9m squared plus 12m plus 4 equals 0. So we can work with this using guide number or other factorization methods, or if you want you can use minus b. It's absolutely fine. And 2 plus. And you'll notice at this point that the two brackets are the same, and that makes sense because we only want one value for m. So the fact that we're only getting one value for m, that's exactly what we want, and it works out as minus 2 over 3. And at this point here, you might realize because we only want one value for m, we're probably going to get the same bracket, and this is actually a perfect square and can be written as a bracket squared. So by taking the square root of the first and the square root of the last, you'll be able to see that either. You can of course use minus b, there's no issue. And this does become a little bit more complicated than the second method, but I suppose you are at least starting it in the right direction. And what we tend to find is there's a lot of marks going for starting the question well and putting it in the right direction. Finishing it off, not so much. If you do something completely incorrect at the start of the question, you might end up with no marks because you haven't demonstrated any knowledge of how to work with the question you've been given. So I would just say make sure if you aren't using this method, if you're going to use the next method I'm going to show you, just make sure that you're comfortable when you use one and when you use the other. It is an important skill that you need to have to be able to work with quadratics that are not particularly nice. Especially if you look at this one here where there was 2x squareds where we needed to combine them to get a single coefficient. So this is a very, very good question. It's bringing a lot into it. It's asking a little bit about the modulus or the absolute value. It's asking a little bit that we need to use with the discriminant. It's asking a little bit we need about like just plain algebra of squaring brackets, simplifying and so on. So method 2 then is looking at using two separate linear equations. So the idea that the absolute value lines means whatever is within those must be positive. So if it's already positive, that's fine. If it's negative, then it has to change to a positive. So you end up with two different scenarios here. So scenario 1 is where this thing is already positive. So 2x minus 3 is positive and it's just equal to mx plus 1. The second scenario here is if that was negative. So if that was negative, effectively what's have to happen is the sign had to change. So it was equal to minus mx minus 1. However, the signs then change to make it positive. So we have two different linear equations here, and we want to find where there's m has only one solution. So there's only one value for m. So if we can isolate m in both cases, then they should be equal. So we have minus 3 minus 1 is equal to mx. So mx is equal to 2x minus 4. So m is equal to 2x minus 4 all over x. The other scenario here we have 2x minus 3 plus 1 is equal to minus mx. So minus mx is equal to 2x minus 2, changing our signs. Mx is equal to minus 2x plus 2, and m is equal to minus 2x plus 2 all over x. Now, since there's only one solution, both of these would have to be equal. So therefore, 2x minus 4 all over x is equal to minus 2x plus 2 all over x. So getting rid of the fractions, multiply both sides by x, which gets rid of both of our x's here. And we're left with 2x minus 4 is equal to minus 2x plus 2. So 2x plus 2x is equal to 2 plus 4. So 4x is equal to 6. X is equal to 6 over 4, which is simplified down to 3 over 2. So that's our value for x. So then we have to go back and find our value for m. So we can use either equation here to sub it back in. So we say 2 times 3 over 2 minus 4 all over 3 over 2. And we're left here with 3 minus 4 all over 3 over 2. Gives us minus 1 over 3 over 2, which gives us minus 2 over 3 as our value for m. So question 3 then, solve the inequality x plus 3 over x minus 4 is less than 2. So this is called a rational inequality, rational because it's given in fractional form. It's really important here that we remember that when we have to multiply across or divide across by a negative number, it changes the signs, which in turn will have to change the inequality sign. Here we've been told that x is a real number and it's not equal to 4, and the reason it can't be equal to 4 is because 4 minus 4 on the bottom line would leave 0, and we can't divide by 0. That it physically can't do it. If you try to divide anything by 0 in your calculator, you get an error. So they're just making that mathematically sound. We need to remember that we don't know the value of x. It effectively will be a range of values for x, but that bottom line could be positive or it could be negative. So you have to be very careful. Generally when we're dealing with fractions in an equation, we multiply by the denominator and that will get rid of the fraction. However, here if we multiply both sides by x minus 4, we could be multiplying it by a negative number. We could be multiplying by a positive number. We don't know. So what we have to do instead is we're going to multiply both sides by the square of the denominator. And the idea with the square of the denominator is we will get rid of the fraction, but at the same time we'll also definitely 100% have a positive number. And because we have a positive number, then we won't have to change our inequality sign. So I'm going to multiply here by x minus 4 squared, and here by x minus 4 squared. One of these cancels with one of those, and we're left with x minus 4 by x plus 3 is less than 2 times, I'm going to square this out, x squared minus 8x plus 16. Multiplying this out, you get x squared plus 3x minus 4x minus 12 is less than 2x squared minus 16x plus 32. So bringing everything across the equals, we get an x squared minus 2x squared. Cleaning this up, we get a minus x plus 16x. We have a minus 12 and a minus 32 is less than 0. We get a minus x squared here as we clean up, plus 15x, and a minus 44. Now, when we're dealing with quadratic inequalities, it's generally better always to deal with the positive. So at this point here, we're going to change the signs. But when we change the signs, we also need to remember we have to change the inequality. So what that leaves, x squared minus 15x plus 44 is greater than 0. And when we come back to that, when we're sketching and so on, this is the one we're going to use, our last inequality. So next we're going to change it into an equation to solve it, to find its roots, so we can then sketch it. 40 equals 0 minus 4 x minus 11 equals 0, so I get x equals 4, x equals 11. So now for our sketch, so there's our 4, and here's our 11. So we're trying to find where it's greater than or equal to 0. So we're talking about where it's above the axis. So we have two bits. We have where x is less than 4, and where we have x is greater than 11. And that's our solution. Notice that it's in two parts on the graph, so there's two distinct places, there's two distinct ranges, and we end up with two distinct answers. Also, just to take a look here, in our initial question we were given a less than 2. If that had been a less than or equal to, so if we'd had an and equal to the whole way through, we would have ended up with x is less than or equal to 4. However, they've already told us that x could not equal 4, so we would have to account for that ourselves and remove that. So do keep an eye to make sure that your solution is valid for all the values you've stated. And usually that is indicated with, when we have rational inequality, the fact that it can't equal a certain number, which will give us 0 on the bottom line.